This is the question from miscellaneous exercise, chapter three-dimensional geometry, chapter number 11. Uh, the first question is find the angle between the lines whose direction ratios are ABC and B minus C, C minus A minus B. The angle between the lines whose direction ratios are given by A1, B1, C1, A2, B2, C2 is given by cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Right? So this is equal to A1 here is A, B1 is B minus C, B1 is B and B2 is C minus A, C1 is C, C2 is this. We take like that. So cos theta is equal to A into B minus C plus B into C minus A plus C into A minus B all divided by square root of this first term, that means A square plus B square plus C square into square root of A B minus C whole square plus C minus A whole square plus A minus B whole square. Now we will simplify cos theta equal to AB minus AC plus BC minus BA plus CA minus CB by these two square roots. Okay, before writing, let us check what is the answer. AB minus BAC and AC minus AC plus CC plus BC minus BC. So numerator is 0. So the entire answer is equal to 0. So the angle between this is cos theta and theta is equal to pi by 2. Alright, or 90 degree. Now next question is find the equation of a line parallel to x-axis and passing through the origin. Parallel to x-axis and passing through the origin. So let us understand what is that question. We have to find out the equation of a line passing through a point, say x1, y1, z1. You just remember this, x minus x1 by direction ratio, y minus y1 second direction ratio, z minus z1 third direction ratio. Alright, so here x1, y1, z1, these are the points through which the line is passing. So we have find the equation of the line parallel to x-axis. So parallel line is x-axis and passing through the origin. That means x1, y1, z1 is 0, 0, 0. Passing through the origin. So 0, 0, 0 point we got. And the line parallel to x-axis. X-axis is a parallel line. So what are the direction ratios of x-axis? X-axis we consider the line. X-axis makes 0 degree with x-axis, 90 degree with y-axis, 90 degree with z-axis. So direction cosines are cos 0 1, cos 0, cos 90 0, cos 90 0. So direction ratios of uh, x-axis is 1 0 0. So our equation, this equation, if you substitute x minus x1 is 0 by first direction ratio is 1 equal to y minus 0 by 0, z minus 0 by 0. So this is how we write the equation of a line. X by 1 equal to y by 0 equal to z by 0. This is the required equation of the line. Question number 3. If the lines x minus 1 by minus 3, y minus 2 by 2k, z minus 3 by 2 and x minus 1 by 3k, y minus 1 by 1, z minus 6 is by minus 5. All the two lines are given in its standard form. So there is no need of rearrangements. So it is already given in the standard form. So a1 b1 c1 is a1 is equal to minus 3, b1 is equal to 2k, c1 is equal to 2 and a2 is equal to 3k, b2 is equal to 1, c2 is equal to minus 5. So as in the previous case, the angle between them is given to be, they are perpendicular, therefore the angle between them is 90 degree. So the formula is cos theta is a1 a2 plus b1 b2 plus c1 c2 all divided by square root of a1 square plus b1 square. This is equal to 0. So if two lines are perpendicular, we have already a condition a1 a2 plus b1 b2 plus c1 c2 equal to 0. So this condition has been derived from this formula cos theta, and a1 a2 here it is minus 3 and 3k minus 9k plus 2k into 1 2k plus 2 into minus 5 minus 10 is equal to 0. So answer is minus 7k minus 10 is equal to 0, minus 7k is equal to 10, k is equal to minus 10 by 7. So this is the answer to the question. Question number 3. Now question number 4. Question number 4 is to find out the shortest distance between the given lines. You know, the equation of a line is in its standard form is r equal to a plus lambda b. So this part is a, and a of the first line a1, and this is b1, vector b1. So this is vector a1 and this is vector b1, and this is vector a2 and this is vector b2. So these are the vectors which we get from the question, and now the shortest distance formula we know. Shortest distance between line 1 and line 2 is equal to, shortest distance is, you know, b1 cross b2, vector b1 cross b2 dot a2 minus a1 divided by magnitude of b1 cross b2, and this must be taken its absolute value. Now what are the requirements? b1 cross b2 we need, b1 cross b2, that is going to be a vector. So b1 is this, b2 is this. How do we find the cross product? I, j, k, and first vector b1, its components we write 1 minus 2 2. Second component, second vector's component 3 minus 2 and minus 2. Okay, so the answer is I into 4 minus minus 4, that is 8. 2 2s are minus 2 into minus 2 plus 4 minus minus 4, that means plus 4 again, minus j into, see, minus 2 minus 6 minus 8 plus k into minus 2 plus minus 2 plus 6, so plus 4 plus 4. So 8i plus 8j plus 4k is the answer to B1 cross B2. Now along with that, we find the magnitude of B1 cross B2, that is square root of 8 square 64, 8 square 64 plus 4 square 16. Okay, square root of 4 plus 4 8 plus 6 14, 6 plus 1 7 plus 6 13 plus 1 14, 144, that is equal to 12. So we got the 12 here. What is A2 minus A1? That is the next point we have to find out. A2 minus A1. So this is your A2. A2 is minus 4i, and here B is I. Minus 4i minus I is equal to minus 5i. Minus 5i minus 4i, sorry, minus 4i minus 6i minus 10i. So here let me change it. Minus 4i minus 4i minus 6i minus 10i. Okay, minus 0j minus 2j minus 2j. Okay, the cap should be there, and minus k minus 2k, so that is minus 3k, minus 3k. So we got all the terms which we have to substitute in our equation, our formula. So let me erase this part. This is B1 cross B2. So let me substitute it. B1 cross B2. B1 cross B2 is the vector 8i plus 8j plus 4k, that is B1 cross B2, dot A2 minus A1 minus 10i minus 2j minus 3k, all divided by B1 cross B2 magnitude, that is a number 12. All must be put in this absolute value. 8 into minus 10. How do we find the dot product of two vectors? Multiply the corresponding components. So minus 80 minus 16 minus 12. Alright. So this is divided by 12. So 8 10 108 by minus by 12. So what is 108 by 12? That is equal to 9. Minus 9, if you take absolute value, 9. So 9 units is the answer. The last question is question number 5. Find the vector equation of the line passing through the point 1, 2, minus 4 and perpendicular to the two lines. So first we take this part. Find the vector equation of the line passing through the point. Passing through the point, the equation can be written as x minus 1 divided by a, that we don't know as of now, and y minus 2 divided by b, and b also we don't know, Z minus minus 4, Z plus 4 divided by C. So this is our equation in the Cartesian form. Now this line is perpendicular to the other two lines. So this is our line. Our line direction ratios are A, B, C. Let us mark it like that. This is our line, and this line is in space and it is perpendicular to the other two lines. That means perpendicular to this line and this line, and these are respectively their direction ratios 3, minus 16 and 7. And another perpendicular line is also given. It is in space, that will be in different orientation, but in the two-dimensional plane we can draw like this only. Anyway, 3, 8, minus 5. Okay, 3, 8, minus 5. So this is our line and this is the given lines. And this line are perpendicular. That means their direction ratios are given. So that means 3a minus 16b plus 7c is equal to 0. They are perpendicular using the result in previous problem. 3a minus 16b plus 7c is equal to 0. So we consider these two, and while considering these two, they are also perpendicular. So it means that 3a plus 8b minus 5c equal to 0. 3a plus 8b minus 5c equal to 0. Now what we do is we use another method. A, B, C, we write like this, and we write 3 here, minus 16, 8 here, 7 minus 5 here. Once again we repeat 3, this is a kind of cross multiplication method, minus 16, 8. So what we have written is, we have written these 3 columns, minus 6, 8, 16, 8, 7, minus 5, and the components we have written. Okay, again these components are once again repeated. Now what we do is a by, we write a by 16 into 5. 5 into 16 is 80. 80 minus, so we write in this way, 80 minus 8 sevens are 56. Okay, now b divided by 7 threes are 21 minus 5 threes are 15, minus 15 plus 15 equal to c divided by 3 8s are 24 minus 3 16, 48. It means 3 8s are 24 plus 3 16s are 48. A by 80 minus 56, 424. Okay, 24 we got, and equal to b by 21 plus 15, 36. 1 plus 5, 6, 2 plus 1, 3, 36. C by 48, I think 72. Okay, so we got A by 24, B by 36, and C by 72, and I just simplify this by dividing it. That is a common, 12 is common here. So A by 2 equal to B by 12, here also common, 3 equal to C by 6. Okay. Now A is equal to, what we do is some lambda we write. A is equal to 2 lambda. We get A is equal to 2 lambda, B is equal to 3 lambda, and C is equal to 6 lambda. So we got the values of A like this. So what we do is we replace here. Okay, replace here as 2 lambda, 3 lambda, and 6 lambda. And next what we do, common factors, lambda cancelled. So here the final answer of this equation in the in in the Cartesian form is x minus 1 by 2 equal to y minus 2 by 3 equal to z plus 4 by 6 is the answer. But we want vector equation. So we know how to convert vector equation or Cartesian equation into vector form. So this is the Cartesian form, and we write it in the vector form as r is equal to I plus 2j minus 4k, I plus 2j minus 4k plus lambda 2i plus 3j plus 6k. So this is the final answer. So thank you.